Most people who try to learn machine learning quit. Not because it's too hard, but because they waste months on the wrong things. They binge watch lecture series, memorize math that they'll never use, and never actually build anything. Now, I've seen it hundreds of times, and in this video, I'm going to give you the exact learning path that actually works step by step, what to learn, what to skip, and how to learn it in a way where you're not spinning your wheels for 6 months with nothing to show for it. And it's a shame when that happens because ML engineers are some of the highest paid people in tech right now, and we're talking 150 to 200K plus just for starting roles. So with that said, let's dive in and let me discuss how to learn machine learning like a genius so that you don't give up. Now, I want to start by discussing the trap that almost everybody falls into when they're trying to get into machine learning. Now, that's trying to learn everything before they build anything. Now, people will literally spend 3 months learning linear algebra proofs and never train an ML model. Now, the fix here is to learn just enough theory to understand what's happening, but then immediately start applying this and actually building projects. You learn way more when you're doing hands-on coding, you're solving problems, you're dealing with challenges, and then what you can always do is when you don't have enough theory, you can go back and learn it. Now, I made this mistake myself. I spent a ton of time on math, learning all of the proofs, and I could have been 6 months further ahead had I just started building at the beginning. So what you're gonna see in this video is that a lot of this comes back to just build, and when you don't know what you need in order to build the thing that you're trying to build, you go back and you learn that theory. So just keep that in mind. It's way better to fail building something first. We can always learn the theory later. So with that in mind, let me go through step by step what you actually need to learn and what you can skip. Now let's start with section 1, which is Python fundamentals. Now this is absolutely essential. You need to know Python. Not Julia, not R, not another programming language. Python is the first thing that you should learn even before you get into any math or theory. Now you don't need to be an expert here, but you do need to be comfortable with the following. So variables, loops, functions, data structures, so things like lists, dictionary sets, file handling, basic object-oriented programming, and that's really it. Of course, there's some other features that you're going to learn, but again, you can pick those up when you need to know them. Don't spend months trying to learn all of it right here. Realistically, you want to spend maybe 3 to 4 weeks getting comfortable with Python, and your goal should be able to write small programs on your own. Read in a file, print out the outcome, right? Or add something to it. Create a simple CLI-based game. You don't need to be a Python expert, but you do need to be comfortable with the basic syntax so that you can read machine learning code and start writing basic scripts. And that's something to keep in mind is that machine learning typically doesn't involve a massive amount of code. It's usually smaller scripts and more having an understanding of what it is that you need to do. So the faster you get into actually writing and building things, the more you're gonna learn. And to be honest, you'll pick up a lot of the fundamentals along the way. Now, with that in mind, there are a few key Python libraries that you are gonna wanna look at though, and that kind of tie into these fundamentals. Now, the first is gonna be NumPy. This is for arrays and math, and it's gonna be used behind the scenes from a lot of other modules that you'll look at. The next is Pandas. This is for data manipulation and looking at large amounts of data. And then the last is Matplotlib. This is for visualization, plots, graphs, etc. Now, as a machine learning engineer, you're going to be using these almost every single day. So understand the basics, know how to set them up, how to import them, what a data frame is, how to create a basic plot. It really doesn't take that long, and even just an hour tutorial is going to give you a really solid base before you move on to the next stage. So now let's talk about everybody's favorite subject, which is math, but specifically the math that you actually need to know. Now, yes, there is a little bit of math that you are going to need for machine learning, but it's not as theoretical as a lot of people like to make it out to be. And to be honest, this math is not super complex, and you don't need to be able to derive it or know all of the proofs. You just need to have a high-level understanding. So here are the areas that actually matter. And again, it might sound complicated, but I promise you just a few weeks of looking at this, and you're going to be much more comfortable with it than probably you would have imagined. Okay, so first we have a linear algebra basics. So we're talking about what is a vector, what is a matrix, things like dot products. Then we're looking at probability and statistics. So what is a distribution, Bayes' theorem, mean, variance, okay? Next, we look at calculus. So just the basics like what is a derivative, what is an integral, for example, and what is the concept of gradients and how optimization works. Now that's really it. You don't need to be able to derive all of these algorithms or write them from scratch. You just need to have looked at them before, understand at a fundamental level kind of why they work or what they are, and be able to say, oh, derivative, yeah, I know what that is. Could I derive this function? Probably not, but I'm at least familiar with the concept. If you know that, you're already going to be at a decent level for mathematics, and it's really only if you're going into super deep research or really advanced machine learning that you're going to need to actually be good and solid in these topics. I myself learned all of this in university probably 5 or 6 years ago now. I forget almost all of it, but I at least am familiar with the word, and that already gives me enough basis to jump into some machine learning algorithms. And as always here, if you find that you do need to know this math later, then that's fine, go and learn it, just don't make it a strong prerequisite that stops you from building immediately. So now let's move on to the next section, which is core machine learning algorithms. Now, once you've got the Python out of the way and you know a little bit of those fundamentals when it comes to the math, and you can even learn those alongside these, you want to start looking at core machine learning. Now, there's kind of some different categories that we look at here. The first is supervised learning, then the second is unsupervised learning. Now, within supervised learning, you have a few algorithms that you're going to want to be really comfortable with, and that you're actually going to want to write, run, and train yourself. Now, we're talking about linear regression, logistic regression, decision trees, random forests, SVM or support vector machines, and then k-nearest neighbors. Now, these are core machine learning algorithms. They're very simple, and to be honest, most machine learning that you see nowadays uses some form or variant of these. Now, after that, we have unsupervised learning. Now, that's where we talk about things like k-means clustering and PCA, like dimensionality reduction. There's also a few others here, but those are the most popular. Now, for each of these algorithms, you want to understand what problem it solves, when to use it versus the alternatives that exist, and how to evaluate it. So what's the accuracy? What's the precision? What's the recall? How do you do cross-validation? If you can understand that, then that puts you in a really solid place. Now, in terms of playing with and using these algorithms, you're definitely going to want to be looking at scikit-learn. This has a really clean API, great documentation, and it's really the go-to place for these kind of classical machine learning algorithms. Now, again, the key skill at this point is that you want to know how to pick the right model for the right problem and not just how to randomly run code. Now, in order to do this, like I said, use scikit-learn and then build some small projects, right? So predict housing prices, classify emails, cluster customer segments, look at real data sets and real problems. There's all kinds of great tutorials out there. And again, you just want to be super comfortable with the basics before we move on to anything more advanced. Now, if at this point you're convinced that you do want to learn machine learning, but you want to do it without wasting months stitching together random tutorials, then I really recommend DataCamp. Now, I've partnered with them for this video, and that's because I've used DataCamp for years to level up my own Python and machine learning skills. And what I like most about it is how hands-on it is. Now, you're not just watching lectures, you're learning by doing. So you're writing code in your browser, getting instant feedback, and building real projects as you go. Now, if you want a complete curriculum that's focused on the model development side, the best place to start is their machine learning scientist track. That gives you a structured path through supervised and unsupervised learning, feature engineering, model validation, XGBoost, NLP, and even deep learning with PyTorch. So you're learning the skills that actually matter for real ML work. And once you can build models, the next bottleneck is going to be production. Now, that's where their machine learning engineer track comes in, because it covers the stuff that most self-taught people struggle with. So ML flow, Docker, data versioning, monitoring, drift, CI/CD. So you can go from my model works in a notebook to my model actually works in production. Now, you can also prove your skills with DataCamp's track credentials and certifications, which is great for your resume and for your LinkedIn. Now, DataCamp is trusted by over 19 million learners. You can try both of these tracks for free with the link in the description. And I genuinely wish that I had this kind of structure when I was starting out. Anyways, it would have saved me a lot of time, but now let's move on to step number 4, which is deep learning. So once you're comfortable with classical machine learning, you want to add on neural networks. Now, you want to start with the following concepts: what a neuron is, things like layers, activation functions, forward and backward passes, loss functions, optimizers, and backpropagation. Now, the framework that I suggest you look at here is PyTorch. This is a lot more modern in 2026. TensorFlow still exists, but PyTorch is really dominating research, and it's increasingly just more popular in kind of the production standard, so you're probably going to be better off with that. Now, this framework allows you to do a ton, but specifically to build out neural networks. Now, the key architectures that you want to look at when it comes to neural networks is going to be feed-forward neural networks, CNNs or convolutional neural networks for things like images, RNNs or recurrent neural networks, and then LSTMs for sequences. And then you want to look at things like transformers, and this is the current architecture behind every LLM, so that's probably going to be an interesting one to check out. Now, you don't need to be able to build a transformer architecture from scratch on day one, but to understand things like attention and how it works is going to make you a lot more effective even just with modern AI tools and give you a non-black box understanding of what's actually going on. Now, in terms of some projects that you can build here to help learn this, you can look at an image classifier with CNNs, sentiment analysis with a simple RNN, and then you could even fine-tune a pre-trained model from something like Hugging Face. Okay, so that's step 4, neural networks. Now let's move on to step 5, which is the skills that actually get you hired. Now, this is where most roadmaps actually stop, but I want to go over things that you need to learn if you actually want to get a job. Because all of this is fine. You're going to have fun. You're going to build out models. It'll be really interesting. But if you go into a job interview, they're going to ask you about all of these things. And if you don't know them or you don't have experience, you're going to be cut immediately. So first, we're looking at ML ops and specifically deployment. So things like Docker, model serving, so fast API, Flask, inference servers, things like monitoring, CI/CD, and setting up basic ML pipelines. As you get more advanced with machine learning, you actually realize that a lot of a machine learning engineer's role is not just to build the model, but actually to deploy it so people can use it and it works in production. Next, working with real data. So data cleaning is literally 80% of machine learning work, and nobody warns you about this before. When you're doing tutorials, you get all this clean, beautiful data with everything existing, but in the real world, you have messy data, missing values, weird distributions, etc. So get comfortable with that early, cleaning, parsing data. Next, feature engineering. Now, often the difference between a mediocre model and a great one is feature engineering. So having domain knowledge can actually matter more than the algorithm choice in many real-world problems. Next, version control, but specifically for ML. So of course, we're talking about Git and GitHub, but also tools like MLflow and then weights and biases for experiment tracking. Next, we talk about cloud platforms. So you want to know at least one of AWS, GCP, or Azure. Personally, I recommend AWS, but really you can go with anything that you want here. And then you're going to be looking at tools like SageMaker, Vertex AI, Azure ML. You get the idea. Now, overall, the people that get hired to do machine learning in the real world, right, who aren't just, maybe junior interns who are just starting out, are hired because not only can they make the machine learning models, but they can serve them and use them in production. That's oftentimes where the bottleneck is, and especially now where a lot of the hard work is already done and you're kind of just fine training or using existing models, that production side is super, super important, so don't skip these skills. So now let's talk about how to actually learn these skills effectively. Now, the rule that I usually present is the 70-30 rule, where you want to spend 70% of your time on building projects and then 30% of your time on theory and courses. Now, most people do the reverse of this, and the ratios you can obviously play with, but generally speaking, you want to have at least double the amount of time actually building, being hands-on, working on the computer, making mistakes, messing up, right? Compared to when you're just watching tutorials or reading through theory. Now, another thing that I highly suggest, especially in this field, is to learn in public. It's not mandatory, but I do suggest that you post your projects on GitHub, write about what you're learning on LinkedIn, right? And that's because specifically in ML, recruiters are hiring based on what you've built, not just what certifications that you have. And this is a field where it does actually make sense to post a cool video about a neural network that you trained or a cool project that you worked on, and it's not going to come across as kind of snobby or arrogant. It's something that's genuinely interesting. And I have a lot of friends in this space who are constantly talking about what they're doing because it keeps them up to date, keeps them relevant, and gives them a lot of opportunities. Again, this is a field where you need to stay adaptive, you need to keep learning, and if you keep posting and talking about it, it at least shows that you're in the industry and that you're active and you're not just a dead LinkedIn profile that hasn't touched this in multiple years. Next, don't tutorial hop, right? Pick one structured resource and finish it before you jump to the next thing. Half-completed courses really don't teach you anything, and you want to get that dopamine hit of actually completing something in full, even if it's not 100% the best resource. Next, when you get stuck, and you absolutely will here, that's a signal to go and learn some of the theory. So you have the context now, you also have the end motivation for why you want to learn something, so now you can go and pick up the math. Now you can go and learn another module. Now you can go and pick up those pieces of syntax. It's always easier to learn when you know why you're going to learn that thing, and you're not just learning it in isolation, detached from a goal or from a project. Next, make sure that you build end-to-end projects. So data collection, cleaning, training, evaluation, deployment, doing this is going to teach you a lot more than doing 10 random Kaggle notebooks, okay? Now, in terms of a time estimate here, if you're super disciplined and you already have some programming knowledge, you can absolutely be job ready here in 6 to 9 months. Now, it's not going to be 6 weeks, right? But it's also not going to be 3 years, 6 to 9 months of focused work. And while it may seem like a lot, in any field, that's really a short amount of time if you just spend it focusing on the right tasks and again, building before learning theory. Now, my honest take here is that ML is one of the most rewarding skills that you can learn right now, but only if you learn it the right way. The biggest trap is just staying in that learning mode and never building anything, and that's because you don't need a PhD, you don't need to understand every single paper, but you do need to actually be able to solve problems, which is the hard part and what a lot of people don't focus on. Same thing like I talked about before, the deployment is a really important stage here, so don't skip that or wait until you get into your first job interview. If you follow the roadmap here, I guarantee that you're gonna have some success. Keep chipping away at it. It's absolutely worth it. With that said, guys, I hope you enjoyed. Leave a like if you did, subscribe to the channel, and I will see you in the next video.